Good morning. The title of our project is Implementation of LUT log map and BCJR algorithm in a turbo decoder architecture for energy efficient wireless sensor network. This is Arun Vivian. Turbo decoder involves turbo codes. These codes are the most significant achievement in coding theory. Turbo codes are considered for energy constrained wireless communication applications. The principle of turbo decoder is iterative decoding, in which soft decisions from different encoding streams are compared and reassessed. The process is also known as soft in, soft out. It provides a better estimate of actual bit level, and after a certain number of iterations, a hard decision output is generated. The turbo encoder processes a block of k information bits, which later produces parity bits. This is fed into the interleaver and the other encoder. It also produces k parity bits. The output of turbo encoder is a multiplex of actual information and the parity bit sequences. This is fed into the turbo decoder. The operation of turbo decoder will be explained by Mr. Arvind Kumar.
Hi, this is Arvind. Turbo decoder is used for error correction. That is, it is used to detect errors which is present in bits and also used to correct those errors in bits in order to get distortionless free output at the end of decoding process. Basically, the architecture of turbo decoder is constant. It has two decoder blocks and an interleaver. Each decoder block in the architecture has an appropriate algorithm. Usually, work of decoding block is performed by the algorithm present in the block. In existing system, the algorithm used to decoding block is B2B algorithm. The drawbacks of using this algorithm is that it accepts soft input and produces hard output. Moreover, the main drawback of B2B algorithm is power consumption is high, speed is low, as well as delay is high. In order to overcome those drawbacks, we presently modifying the algorithms in the decoding blocks such as max log map and LUT log map. The main function of max log map is used to detect errors in forward direction, which is known as forward recursive algorithm. If any error is present in forward direction, it will detect and correct those errors. The main function of LUT log map is used to detect errors in backward direction. If any errors present in the backward direction, it corrects those errors. It is also known as backward recursive algorithm. The max log map is used to find the maximum probability of next state, which is used in Trellis diagram. In the LUT log map, all the maximum probability of next state is stored in one table, which is known as lookup table. The performance of LUT log map is to choose the best maximum probability from the table, and thus by using those two algorithms, we can trace the minimum Hamming distance. If Hamming distance is less, power is less, speed will be more, and delay will be less. So we can attain the correct output at the decoding block.
So let us see the simulation of a project. For that we need Xilinx software. We use version 12.3 here. To perform new project, we choose File, New Project, New Source and Verilog module. The information is encoded and then sent to the decoder, so we write the module for encoder first. Click Implementation under Synthesis and choose Check Syntax. Click Simulation and under LSIM Simulator choose Behavioral Check Syntax and Simulate Behavioral Module. By doing so, we obtain the encoder simulation. By clicking View RTL Schematic under Synthesis and Implementation, we obtain the schematic of encoder. This is the encoder simulation. Next, we write the module for decoder. As we did before, click Implementation and under Synthesis choose Check Syntax. Click Simulation and under LSIM Simulator choose Behavioral Check Syntax and Simulate Behavioral Module. By doing so, we obtain the decoder simulation. By clicking RTL Schematic under Synthesis and Implementation, you obtain the schematic of decoder. Now we write the module for B2B, that is the existing. Again click Implementation and under Synthesis choose Check Syntax. Perform Behavioral Check Syntax and Simulate Behavioral Model under Simulation. This obtains the B2B decoder simulation, and to obtain the RTL schematic, click RTL Schematic under Synthesis and Implementation. Now, to analyze power, we perform implement design, place and route, power analyzer under implementation. We can see that the power consumed is 24.80. Similarly, we analyze the power for turbo decoder by repeating the same steps.
we can see the power consumed is now 23.60. Thus we conclude by saying that turbo decoder consumes less power than existing Viterbi decoder. This ensures that turbo decoder is efficient than Viterbi decoder.